All right, the remainder theorem says if a polynomial f of x is divided by x minus k, then the remainder is the value of f of k. So here it asked us to use the remainder theorem to evaluate this function at this point. So normally, what we would normally do if we didn't know about the remainder theorem, if they ask us this question, all we would normally do is we would just plug in 2 into this equation, right? If you plug in 2 into this equation, you get 6, 2 to the 4th, minus 2 to the 3rd, minus 15, 2 to the 2nd, plus 2 times 2, minus 7. And you plug all this in, just in short, you will get the number 25, right? If you plug it in. So normally, that's what we normally would do, right? Normally, we would do this. But right now, we don't want to do the normal way. We're actually going to use the remainder theorem. So using the remainder theorem, and you might be wondering, well, why are we doing the remainder theorem when we could use it, when we could just do it our normal way, right? And the reason why is because it's going to be a skill that we're going to need in a future section. So right now, in this 5.4 section, we're learning skills. We're learning how to do synthetic division, and now we're learning how do you evaluate something using the remainder theorem. And the application of it will come in a future section. So using the remainder theorem, it tells me in order to find f of k, or f of 2 in my problem here, if I want to find f of 2, I could divide this, and then whatever the remainder is will become the answer 25. So let's go ahead and try doing synthetic division with this. So we're going to do synthetic division, and then using the remainder theorem, whatever the remainder is in synthetic division, the answer will be 25. I'll show you. It'll end up being f of 2 is equal to 25. So let's get into try this. So we'll do this together for the sake of time. What are the coefficients? Well, first of all, is it in order? 4, 3, 2, 1, constant. It is in order. So I don't need to change anything around. It's all good in the hood. So I'm going to write down these numbers. These numbers are going to be 6, the coefficient 6. What is this coefficient? -1, the next one. -15, the next one. 2, and the next one, -7. Great. And then I'm going to write down what is it says at x equals to 2. So instead of saying divide by x minus 2, they're telling us what the 0 is going to be, right? Or they're telling us the number. So this x equals 2, we just plug the 2 right there. Right? We don't put -2 because we're not doing divide by blah, blah, blah. It tells you what to put this in as 2. And then I'm going to go ahead and try to do synthetic division with this. So let's try this out. So first step is to drop it. We get 6. And then what do I get when I multiply? 12. Add these together, I get 11. Multiply, I get 22. Add these together, I get 7. Multiply these together, I get. Add these together. Multiply. Add. 25. Holy smokers, right? The remainder theorem says that the remainder of synthetic division, when you do this, is the answer for when you plug in f of 2 into this function, you will get 25, which is exactly the same answer as if you plug 2 into the original equation, you got that, right? And that's what the remainder theorem does.